Thanks for the introduction. So my name is April Guymon, and I'm the Director of Monitoring Base Commissioning for ETC Group. I don't know if you can see me over this. Put that down a little bit. And I'm really excited to be here and share with you details about monitoring base commissioning and hopefully share a vision of what it can be like. Before I get started, I wanted to ask or kind of relay a little personal story. Recently, my family and I took a trip to Boulder, Utah. Has anyone ever heard of Boulder, Utah? I'm going to be shocked if anyone has. No? Okay. Not Boulder, Colorado. This is Boulder, Utah. It's an incredibly tiny town in southern Utah, and it is just beautiful. It has access to amazing slot canyons. It's in the desert. There's waterfalls and swimming holes that you can get to really easily from there, and beautiful hiking. It's just this really beautiful place. And recently, when we drove there, the only road into and out of Boulder is called Scenic Byway 12, and it's just this completely spectacular drive. It's stunning. As you go along, the road is like a ribbon, and it follows the contours of the rocks, and at one point, the whole road rises along the spine of a bluff, and you can see for just miles on either side. It's just a really fun road to drive. And I was thinking there has to be some interesting history to this road. Who thought to put this road here? Who thought to put this town amongst this beautiful landscape? And I did a little research and found out that road was built Scenic Byway 12 was built in 1940. And prior to that, the only way to get to Boulder was by pack mule on a trail called the Death Hollow Trail. It was very ominous. And it's the only way that you could have gotten there, which makes it the last pack mule accessible town in the entire continental United States. So it's just really remote. And it occurred to me that managing energy efficiency across multiple buildings can be like driving on this really smooth road like the Scenic Byway 12, just this really great experience. And it can also be like taking a pack mule across the desert on the Death Hollow Trail. It can be really terrible. And so what I'm hoping to share is what I think is the road to success to building a monitoring-based commissioning program, which I think is the best way to achieve persistent energy efficiency across multiple buildings, across an entire enterprise. Okay, we'll move on to the next one here. Okay, so the learning objectives. We're going to talk about how to use analytical technologies as a tool to finding out what energy efficiency issues are happening across the entire enterprise. We're going to talk about, just as important, how to structure an organization to maintain that high building performance. That's just as important as the technology piece. We're also going to talk about what can you monitor beyond energy. We're going to hit on comfort, occupant comfort, compliance, and maintenance. We'll also talk about how to implement effective reporting, so how to communicate what's happening across your entire enterprise. And then finally, we'll touch on how to begin down this road. Okay, so I think we need to start with what is monitoring-based commissioning and why monitoring-based commissioning. So hopefully this is, this is probably a familiar story to a lot of you. This is a facility that underwent a recommissioning project, so an energy-focused project to improve the energy use in that facility. So let's see. Back one. Okay, these green bars represent the energy use in the facility. So you can see before this project starts, this first blue line, the bars are really high. There's a lot of energy use in this facility. And then as the project executes all the way to here, the next arrow, the energy is decreased. So the project is successful, everyone's really happy, the energy is down, it's really great. But the story that happens over and over after a project like this is energy starts to go back up. And that's called drift. And drift is really the reason monitoring-based commissioning exists. It's because executing a project and attaining energy savings is attainable, but how to make those persistent is a lot more difficult. So the tools and techniques that really comprise monitoring-based commissioning are about getting at this drift. That's where it came from. Okay, here's another visual going a little deeper about how these tools and techniques can be used. The first arrow again, so over here on this axis we have energy use, so the higher, the more energy in the facility. This is showing recommissioning as this blue arrow. So we drive energy efficiency up, energy use down with the recommissioning project. And then if we do nothing, this is the drift that would happen. We'd increase over time. That's typical. But what we found is if we use these tools during the recommissioning process, so early in the process, use these analytical tools and technologies we'll talk about and techniques, you can actually drive your recommissioning project, not just this first chunk, but even deeper. We lovingly call that the deeper dive when you use these tools for recommissioning. And then after that, after the project is over, if you leave those tools in place, you can drive your energy even further over time instead of that drift happening. So the opportunity of these tools and techniques we're going to talk about is really this entire, they look like the same color up here, but it's really this entire area is the opportunity to go after with these tools. So it's pretty exciting. It's more than just persistence. It's really getting deeper into energy. Okay, so let's talk about the tools that are available and how to use them. I thought it would be really good to kind of give an overview of one organization that we work with and what they've deployed to give you a sense of what it can look like. So their enterprise statistics are that they have one analytical platform that they log into, one place they go to see all of their relevant data about their building automation system or whatever the data source is to manage their energy. So they have one platform, analytical platform they log into. They have 28 connected facilities. So 28 buildings that are feeding in their building automation system data into that one platform. And then within that platform, there are 170 different rules. So rules is a condition-based algorithm. So it's some computer programming that's taking all of that data and processing it and turning it into analytical results. So it's saying things like, oh, you've got a leaking chilled water valve, or you've got a leaking hot water valve. It's taking all the operational data and giving results that are actionable. So they have 170 of these rules running at their across their organization. They also have 67 total KPIs. So KPIs is kind of a buzzword, but it's the key performance indicators. So these are the things that you want to pay attention to over time in a facility to be sure that you're able to properly benchmark and understand the facility through time. So things like the chiller plant efficiency. How has that changed over time? Things like the energy use per square foot. Just really high-level numbers that help you understand whether you're degrading or improving over time. They also have 73 different chiller monitoring devices. So these are separate from the building automation system, separate from the onboard chiller controls and data that comes out of the chiller. These are actually data acquisition units that collect data about the vapor compression cycle of the chiller and report that back into the same analytic platform. So they're able to see really deeply into all of their chillers. They also have over 13,000 terminal units. Anybody in here dealing with more than 13,000 terminal units? Just wondering. Yeah, close. Okay, okay, cool. Okay, so listen to this part. They have 13,000 terminal units. That is so many devices. There is no way to go into a control system and effectively get ahead of issues with 13,000 different pieces of equipment. And this is where a lot of that power comes in to being able to push all that data forward into an analytical platform and find issues across a huge set of equipment. Their single biggest facility has 1,600 terminal units all by itself. So there's a range of size of facilities here, but that gives you a sense for how much they're trying to get their hands around to manage. Some example rules, I gave just a quick flyby on those rules a second ago, but I just want to speak a little bit to what kinds of rules have been deployed. at this organization. So the top 3 are about air handling units. So these are rules that are looking for things like chilled water or hot water valve leaks. So it's taking temperatures that already exist in the building automation system, and it's identifying whether or not there's a leak in some of those valves, which is a big energy penalty. It's evaluating whether their discharge air temperature set point reset or their duct static pressure reset in those air handlers is effective, if it's still resetting and if it's doing it in a way that's optimal for the entire system. We can find economizer issues with these rules and identify whether or not you're optimized for getting the most out of free cooling. There's a whole bunch of them on this list, and it'll depend on what your system has, what kinds of devices and systems are in your facilities, on what's useful in these rule sets. But I wanted to point out particularly these are the rules that are targeting these enormous amounts of terminal units, all the VAV boxes and fan coils that are out there. These are just a sample of them. So looking for things like, do you have a hot water valve leak in any of these units? Do you have a closed damper, but for some reason you're still getting airflow? There's something wrong with that damper. Zone air temperature set point that's not met, causing uncomfortable conditions in the space. So things like that. So this is just to give you a sample of the types of logic that can be programmed into these analytical platforms to help you find issues that you deal with all the time, every day, but manually doing it over and over, and instead you turn it over to the data to tell you what's wrong. It does not correct it automatically, no. And we'll get to how you get through that process. Great question. Yeah, I don't want to oversell it. There's no robots out there fixing the dampers. Okay, so this is an example screen of what an analytic return could look like. This is a facility that underwent a recommissioning project. A lot of different measures were implemented during this recommissioning project, but the major one was scheduling. So this was a facility that was running 24/7, but really it only needed to run, it was only occupied from like 8 to 5. So that was the major opportunity in this facility. And as it moved into monitoring-based commissioning after the recommissioning project, we started to see some of these rule results, these analytical results, come back to say that this, whoops, sorry, I keep pushing the wrong button. This list of VAV boxes over here is not meeting its schedule anymore. And everywhere there's a little purple box that is showing times when it's supposed to be scheduled and it's not. It's no longer scheduled. So this is an example of that drift. It's somebody slowly rolling back that schedule. And so this result came back to us, and we had a conversation with the facility and asked why. Why did these get rolled back? What was happening here? And it turned out that they were getting a lot of complaints about it being too hot. And so they thought, okay, it's the scheduling. That just happened. That must be. So they started to roll it back. And we looked into the data and we found they were right. It was too hot. We believed them. And when we got into it, it turned out that these legacy controllers that were on these VAV boxes had some really buried settings that were taking the unoccupied temperatures to these just 85 degrees, just these astronomical temperatures that did not make sense, and they couldn't recover. So it wasn't that scheduling was happening, it's that some settings were incorrect. So they went back, they fixed those settings, and then they were able to recover their schedule and put it right back and gain all of the savings they get, particularly, if you notice, all day on Saturday, which is a really big chunk of where the savings were. So we were able to stop the drift, recover the savings through these results quickly by seeing these things. And, unless you're going to stay up or dig through trends, you're not going to be able to see this stuff very easily. You have to get into the data yourself manually to find this. So this is a good example of when it just all came together and it worked really well. This is the example of being on scenic byway 12. You're just driving along, everything's smooth. You're able to accomplish what you need to accomplish. This next example is more like being on that Death Hollow trail. It was very painful and arduous. And it's an example of some of the complications and pitfalls of analytic technology. You don't just plug it in and everything goes smoothly right out of the gate. So I wanted to share this example just to be real a little bit. Okay, so this facility underwent another recommissioning project. Things were implemented like chiller resequencing, air handler resequencing, terminal unit control resequencing. Just a huge amount of different measures were implemented, and the project was really successful. And you can see here, this is a measure of savings this time. So the bigger the blue bar, the more savings there were in this facility. Okay, so same story that we've already been seeing. That blue bar starts to shrink over the months, and it just starts to go down. Okay, so this is where it was really bad all of a sudden. This one I could kind of be like, well, maybe that's weather. But here it starts to really evaporate. So we started to look at all of our resources. We were using the analytic platform. We were looking for any changes in the KPIs or analytic results that were telling us there were problems, and there was nothing. Everything looked awesome. The chiller plant efficiency was exactly the same. The loading was the same. Everything was coming back as very reasonable and persistent. And down here at the bottom, one of the KPIs that we looked at was average fan power. So that's average fan power for the air handlers in that facility. We started to ask questions and realized, well, we already knew this, but there was a big data center in this facility, a really big data center. And that data center was cooled by CRAW units, so computer room air handling units. And it had been excluded from the scope of that energy project at the beginning. And so everybody had kind of ignored it. We'd all just put it aside and left it alone to its own devices. And what we learned from digging around is that we actually had information about those CRAW unit fans that we didn't know we had, cleverly disguised as the UPS A5 power lines 1, 2, and 3. So we found out that this is the UPS that's serving those CRAW units, and you can see the jumps and increase in power that's happening. Let's see, right here, like this huge jump, and that jump completely lined up with the savings that we were seeing lost. And it turned out that there was a programming bug with these units, that under certain conditions, their fans went to 100%, where they normally operated around 30% on a typical day. So it was this. So we went for months not knowing why the energy had increased, and it was this mystery. And it was a good example of how persistent and curious you need to stay undergoing a process like this, and how important it is that the data flowing in that you have is correct and clear so that you can get good results in the end. So you can see here our KPI at the bottom. Now for average fan power, there's this huge jump, in this month, and you can see it jump way up, and that was definitely the source. And this one's kind of funny. I've given this presentation before, and just this last week, though, this very building had the same problem happen again. Somebody went back in and reverted the code to the old code. And so this very week we saw these huge jumps in the numbers. And I was like, I know what that is. I know exactly why that's happening. So it's getting fixed again. Okay, so those are just some examples of how using the analytic technology, the data platform, can help you find issues and make your energy efficiency really persistent in your facilities. Now, another really important part of this story actually goes back to your question. Well, how does this get done? Like, does this get done automatically? And the answer is no. Like, people still need to go and execute work. And so thinking about your organizational structure and how you're going to flow that work is really important. For example, we worked with an organization that was really big, and they had a facility team that took care of a single facility. And then those facility teams reported up to a facility manager and a regional manager. And then the regional manager reported up to their corporate structure. So every facility had its own goals. they had their own vision. Some of them were implementing and doing energy efficiency things, and some of them it was way down on their priority list and they hadn't done anything like that before. So they were kind of they weren't really moving forward on the same road together. They were doing their own things. And and the other thing we observed is they had really limited resources under that pattern. They all had just enough money to kind of keep everything going and make everything happen, but they didn't really have the resources to accomplish anything specifically for energy efficiency with the little bit of leftover money they had. And so what we observed is over time, they decided to change their structure a little. And everyone's structure is going to be really different. So this is just an example to kind of highlight some principles. But they organized a central, they call it their ROC, their Remote Operations Facility, or Remote Operations Center. And the ROC was comprised of some energy managers and some data analysts and controls skilled technicians. And what they did is they collected all of the analytical results from the software, they prioritized them, and then they distributed them to the facilities and helped them get the work done. So if they had questions about how to execute the work or what needed to be done, or they didn't have the technical skills that they needed, they were able to go to this central resource and get the things they needed to accomplish the tasks. So they really moved from this kind of siloed organization into a group that had centralized communication. They had a singular vision. They all knew what the goals and the reason for monitoring-based commissioning. They all knew what was happening. And they really could work together. They also decided to change their structure so that they took all of those little bits of resources that were left over and they rolled them up into a combined resource and started to execute the best opportunities and turned that money into more money by getting energy savings. And then they took that money and they did more projects and they turned it into more money. So their combined resources financially also supported them to get more work done quickly. So I've got here, I've just listed some of these things. I really think it can be the difference between feeling like you're stuck and there's really no path forward compared to being on just this really smooth ride. Okay, another part of the organization that's critical, there's so much that you can do internally, and it's also really important to think about what key external partnerships your organization needs to create. And I like to think of vendors not as vendors. I think you buy goods and services from vendors. I think that partners are services and people who you really can trust to deliver you consistently good service and really grow with you. We're talking about analytic technologies that are pretty new to our industry, and they're changing things very quickly. And if your partners are willing to also use that data effectively and grow with you as you use the data, you'll have much more effective results. So I've listed some things to think about here. We don't need to go through each one, but things like selecting a fault detection platform that's going to be around in 5 years, that's going to be able to support you and be effective for what you need. Making sure that you've got the right, I think controls contractors are just so critical to all of this. I mean, most of the data that's flowing into these analytic systems is coming from automation systems. So making sure that you've got a partnership with your controls contractors where they can support you and understand that they need to name things. They need to name things in a way that you can understand, because that data is going to go in somewhere else and be interpreted. It needs to be very clear. You need to have someone who's really on board with making the data as clear and easy to understand as possible. And then here at the bottom, I wrote facility teams because, again, just to go back to it, there's no value in any of this technology if nothing's getting done. I mean, if it tells you all day all the things that are wrong and all the things you can do to improve efficiency, if it's not being executed, it has zero value. So your facility teams are just such an important resource, and making sure that they feel the buy-in, that they feel that this is they can own it and that they can execute well and have the resources they need to do that is such an important part of making sure you're, as a management team, your partnerships with those facilities is really strong. Okay, so I want to tell a little story about when I think all of these elements come together to really be successful and put you on that road to success. There was a facility, a chiller plant with three 350-ton chillers. And the analytics results, so we had these data acquisition devices out there pulling in information about the vapor compression circuit of the chiller. And it was saying that there was probably low refrigerant happening in these chillers, that their efficiency was way down and there was something wrong. And so the facility teams contacted their chiller maintenance vendor to come out and have a look. And so they came out to service the chillers and they said, this is just how the chiller operates. It's fine. This is how they're supposed to work. And the facility team was like, well, but the data doesn't say that. The data is saying that it used to work way better. We used to meet set point and now sometimes we don't. And we're having all these problems. Like the data's not like in line with what you're communicating. And so it went on for a couple of months where they had these chiller service providers come back and they just couldn't resolve it. And so they invited a different chiller vendor to come and have a look at these chillers. And when they got into it, they weighed the refrigerant and found that one of the machines was 550 pounds short of refrigerant, and the other machine was 350 pounds short of refrigerant, which equated to $20,000 a year in reduced efficiency of those machines, just the machines, not even the plant, just those machines themselves. And so it was a really good lesson for that facility management team to know that they didn't have a partner. They had a vendor at the beginning. They had someone who wasn't willing to look at the data and understand where that was coming from because it wasn't part of their normal, it wasn't data they'd ever seen before. And so, they ended up making a new partnership with this other chiller maintenance provider who was willing to grow with them in the new data that they had available to them. And it was just really cool to see how it all came together, everybody working together to really start to get things done and how effective they've been since then working as a team. Okay, so at some point when you've got all this data coming in, we have to ask ourselves, what else can we do with this? I'm an energy engineer, and so that's like kind of what I think about a lot. But there's so many other things to think about with this data that I think were largely ignored previously because it was too hard to get the data to begin with. It took so much time to manually collect it in trend files or whatever you had to do to get it was just too hard. So now we're at this place where data is just available. And so we should be thinking about the cool things we could be doing with that data. And I think the first thing that seems the most obvious is comfort and thinking about comfort, not as a byproduct of energy, but as a main focus. And in this, I think if you ask any facility maintenance engineer or technician what their biggest pain point is, it's that phone ringing with a hot or cold call all day. Like that is their pain point. And so if you can speak to those pain points and help them reduce how many times that phone rings, you can make friends really quickly. You can get buy-in from all those people, and it helps support the monitoring-based commissioning program really achieve the energy success that you're looking for. So this is an example of a comfort report that focuses on these very things. So this is a comfort KPI. So it's the percent of time that zones are meeting their temperature set point throughout the entire building. So this facility is at 89%. Down here is the best opportunities to improve comfort. Trying to give it a positive spin and saying these are your worst terminal units. So these are the 5 terminal units that have the worst comfort. They're not meeting their set point most of the time. And every time I show one of these lists to a facility technician, they're always like, oh yeah, I always get calls about those spaces. And so this helps to give them the data, and then this combined with the analytic results, the rules that we were looking at earlier, can help them to see what the problems are and go fix them. And once they fix these VAV boxes, whatever it is that's wrong with them, so that they're operating properly and providing comfort, this number over here will go up. And they can see the feedback of their work is improving their facility's comfort numbers. Okay, another really important consideration is compliance. There's a lot of places that have compliance requirements for environments. So things like hospitals or laboratories or just any number of spaces that have really rigid requirements on how those spaces should be maintained. So this is an example of an OR compliance summary. So in hospitals, ORs are required to have adjacent space pressure that's positive. They have temperature requirements and they have relative humidity requirements. And so this is a summary of a hospital that has 4 operating rooms. And these are the roll-ups of how they're doing for their pressure, temperature, and humidity in each of those operating rooms. So this is data that's just always been in the control system. It's always been there, but it's not really been organized in a way that somebody can see it and understand, oh, I've got a problem with my operating room. I need to go evaluate that sequence. Because at the end of the day, energy is important, but in a hospital, patient care is far more important than any energy spend. Making sure that patients are safe and in the right environment is so much more important. And so being able to think about if you have spaces that have that kind of critical nature or compliance requirements, well, use the data to look at that. And then you don't have, if you have a survey of some kind coming in, you don't have to wonder how it's going to go. You could know exactly how it's going to go because you already have the data that shows how your performance is. This is an example of a lab pressure report. So this is a laboratory building, a research facility that when we started monitoring their building, every single one, so this is all the VAV boxes that are serving those laboratories in these spaces. And every single one of their compliance percentages for those laboratories was 0 when we first came into this building, like 0. Out of compliance 100% of the time. So they looked into it, and it turned out that somebody had put, they should have put negative numbers in so that it is a chemical laboratory, so all of the labs should be negative to get all those bad fumes out of there. And somebody had put in positive numbers instead of negative numbers. And so everything was reversed, and they were running positive everywhere. And so that's a life safety issue. And that was, we found lots of energy opportunities after this in this facility, but the single most important thing we told them was your labs are positive, and they went and fixed them. It took like an hour for someone to go put negatives next to all those numbers and fix all their labs. So it's another example of where compliance, really speaking to what's important in your spaces beyond energy is an important thing to think about, and that is enabled through this data in monitoring-based commissioning. And they're doing better now. They still have some issues to work out. Those are not all 100% yet, so they've got some work to do. Another really important consideration is maintenance. There's so many things that can be harvested from the data to inform maintenance. I see somebody laughing. I didn't actually see this. I wish I had. This is a friend slide, But one of the most basic thing you can do is pull in that point from the building automation system coming right out of that VFD that's telling you what temperature the VFD is running at. If you have a really hot VFD, it'll fail prematurely, and then you're buying a new VFD where you didn't need to, maybe for some amount of years later. So things like monitoring VFD temperatures, or monitoring pressure differentials in an air handler to predict when you need to change a filter. Those are the kinds of things that can help your maintenance team be more effective on making sure they're focused on how they're spending their PM time or other time. Okay, and then I want to move on to talking about reporting and how a critical piece of monitoring-based commissioning is sharing results. Sharing where you are, what progress has been made. Being really, really transparent about that is really critical. So this is an example of a facility level report to share how the facility is doing from an energy perspective. This particular organization set goals for themselves. So every facility has monthly goals for their energy spend. And they had a goal to hit $20,000 in savings at the time of this report and they hit $20,000. I was so proud of them. It was really cool. Yeah, those numbers don't always match perfectly, so that was kind of interesting. But you can see along here, trying to tell them the whole story. And this really is designed more for technical users. But this is their energy use, their total kBTU in this facility. This is their energy use. The red line is their baseline. The green line is the target they're trying to hit. And the black line is where they actually are. So they're kind of bouncing around in just really kind of uncontrolled and doing a little better and then doing a little worse and then doing about the same. And then the energy project hit and they started to split. So the red line starts to diverge, it's higher, and they started to improve their energy use and exceed their target at, kind of at the end here. And then it's important to know, well, what are your energy sources that are playing into that? So this is a breakout of their electric use and their gas use. If you're a campus, you might have something like chilled water or hot water from a central plant that you can meter. So this could be any number of sources that roll up to that total. But in this case, they're doing really well on their electricity and they're doing really well on their gas. They're kind of just meeting their targets for everything that they're doing. And then over here, we're reporting an EUI. So that's an energy use intensity. It's a kBTU per square foot. And these typically are reported annually. So if you go to CBEX data or other repositories to try to see how you're doing, they're usually annual numbers. I really like to report them on a shorter interval because it's really hard to tell when an annual number changes. If you have one really terrible month all of a sudden of bad operation, it's not going to impact a number that takes into account 12 months for quite some time. Your energy has to get really bad for a while before you can really see it in that annual number. So I like to report a monthly number to let that be really agile, to show quickly when something has gone wrong. So we report on, picking the right metric for your facilities, the right way to communicate what data is understandable and digestible for them, and then making sure it gets shared so they know where they are. Another really important part of reporting is telling them, well, okay, your energy use is good or bad, but what can you do about it? Like what can you do? And this is where the analytics come back into it. This is a table with the top opportunities for a site. So communicating what those opportunities are, being really clear about what they can do to accomplish them, and of course, giving them something to prioritize off of. This particular organization uses dollars. How much opportunity is there in energy savings? So it all gets organized by what are the top dollar opportunities for them. Another really important thing is to communicate those successes. So these are the things that were accomplished by the facility team. So communicating back what they did that's really great, making sure everybody can see their successes, that those wins are being celebrated and shared transparently is another really great way to get buy-in from people. So they're not just out there doing things. Sometimes they're like, oh, is this extra? Is this extra work I'm having to do? And as long as they know that it's important and it's being recognized by people, that really helps them to be more willing to participate in the monitoring program. Okay, and then, so that's kind of at the facility level, but it's really important to have some kind of enterprise level reporting where you're sharing across the entire enterprise so that everybody can see where progress is and where you fall. This is an organization that year to date, as of quarter three, we're saving $1.6 million compared to the previous year. Their targets were about 500,000, so they were really excited to share this report with everyone because they just totally killed their goals. And then this number, this $350,000, these were saving opportunities that have just been identified. So if you look down at this table here, this bar chart, all the green bars, and I know it's too small to read, but all of these green bars are the savings they actually have achieved so far at each one of their regions. And then the gold bars on the top are the opportunities that have been identified through the analytics, quantified, and are out there to get executed. So where should this organization be spending their money? Column 1, 2, 3, 4, 5, or 6? 4. Yeah, okay, 4. So if we just focus on column 4, these are the 6 facilities that are in that region. So which facility should they spend their money on? 1, 2, 3, 4, 5, or 6? 1. Yeah, so stuff like this can make it really easy to tell where the opportunities are and where resources should be allocated to try to get energy savings. Okay, this is that same organization, and this is a summary of what actually what the actual measures are, like what energy efficiency measures can they execute individually. So we report on their top opportunities right here, so the top 5 across the entire organization. And then over here we tell them how many opportunities there are at every single facility and the total value of those opportunities. So these are all the facilities here, and you can see that on that last graph we just looked at when we said 1, it really was facility 2 was the one with that giant gold bar sticking out of the top. So here's facility 2 on the open ticket note, or open note total. So they have the most notes that have been identified. It's kind of a scary number. It's 300. So 300 things to do. And then close this quarter. So these are things that got done. How many things, just in discrete items, got accomplished? And facility 2 is way down here. It's a 0. So if we focus just on that facility 2 with that giant gold bar where all the opportunity is, whoops, sorry. We can see they have the most things to do, the most value of potential savings, and they're not getting much done. So this message went out to the entire enterprise, and the leadership is able to start asking really good questions. It's not really about making facility 2 feel really bad. It's about asking good questions like, why aren't things getting done? What resources do you need? What kind of assistance do you need? What are your obstacles? So this kind of reporting can really help understand not just who's doing really awesome and who's not doing awesome, but also the deeper questions of, is there something wrong with the way that you're operating that we can help you with and make it better? So that's the goal of these facility level these enterprise level reports, are to help bring everybody along and get that buy-in to make sure that everybody has the tools they need to be successful. Okay, so how to implement. I think there's a lot of different strategies that could work here, but I wanted to give a few suggestions if you're considering monitoring-based commissioning in your own enterprise. How to start. I think that I encourage people to start small and test it out. That may not always be the right path, but if you start small and get some quick wins, it can help generate a lot of buy-in so that you can grow the program. So if you have 30 facilities, maybe you started on 3 facilities or 5 facilities to see how that goes and to learn some lessons. I think it's really important too, as you implement a program like this, to evaluate performance as you go and just be willing to discard all the cool things you thought were going to work and let them go if they didn't work at all. So being willing to evolve and change your plan to make sure you stay on that path to success. I think it's also really important to consider standards. So standards in lots of different ways, like if you have standards for certain spaces, so what temperatures are we going to allow these spaces to be at? How are we going to maintain certain pieces of equipment? What kinds of equipment are we going to allow? Are we going to just go with the model of lowest bidder always wins? Or are we going to try to create consistency in the type of equipment or service that we have so that it's just so much easier to deal with consistent data across your enterprise than a bunch of different stuff coming in that's hard to interpret and how hard to know. If you have to create a new plan every single time you come upon the same problem, it's going to slow you way down. So consistency in your standards is a really important thing to think about, how you can implement that. Yeah, and I think that monitoring-based commissioning can be this really, really smooth road, and it can really help you get persistent energy savings. And And I think it's a great way if you're feeling like your energy, if you're just kind of stuck somewhere with your energy program and it's been hard to advance or make it to that destination you've got in mind. Monitoring-based commissioning is a really great tool to achieve those goals. Okay, and that's everything I've got. Question? Thanks. All right, questions?
So the amount of data that can come from overwhelmed goals, what are your suggestions for stay focused?
Yeah, okay. Okay, so the question was the amount of data coming in from these systems can be overwhelming and huge. And so what do I recommend for folding the data, or how to roll it up, or to stay okay, how to stay focused? Yeah, that's a great question. I think the first thing is don't bring in 1 minute data. Like, don't do that. Just don't do that. So for most HVAC systems, 15-minute interval data is totally sufficient to evaluate those systems. So that's the first thing, is you don't need to bring in, just because you can doesn't mean we should bring in like every minute or every second or things like that. So that reduces the overall like interval volume, but also thinking about which points to bring in is another really important thing. So when, you know, and that will be system by system evaluation on what's really critical information from those systems that is going to bring you value by putting it through analytics. And I think, you know, kind of, I always want everything, so it's hard. But yeah, you do have to be careful about not bringing in things that are just going to distract you and make it an overwhelming mess of data, for sure. Yeah. Other questions? Yeah.
What analytic platform do you use?
Yeah, so we use SkySpark. There's a lot of different things out there, but about 5 years ago, we went through a process of, you know, we used a lot of different platforms, and really homed in on SkySpark as the tool that was right for us. And we have we also use BuildingFit. So SkySpark is really, it's kind of like a Windows operating system. It's just the platform, and then you have to build all the analytics within it. So then we buy from BuildingFit, and they make all of the analytics. So they write all the code and the programming for the analytics. So we use both SkySpark and BuildingFit together. Yeah.
So does that integrate with some of the EMS platforms that are out there? Where you just download that data directly in, or do you have to have some sort of...
Yeah, so SkySpark has an open, so you mean out of SkySpark into other systems, or into SkySpark? Into SkySpark, yeah. Yeah, so SkySpark has a lot of, one of the reasons we picked it is because it has a lot of already built connectors, so it can read BACnet and different protocols to read that data in fairly easily. So that's, I mean, that's something that's important to think about when you're picking an analytical platform, is what, you know, how is it going to integrate with all of your systems? And is there something out there that's going to be better than another one? Yeah.
Can you explain the relationship between SkySpark and the other platform you spoke of?
Oh yeah, okay, SkySpark and BuildingFit. I know this is confusing. Okay, so SkySpark is the analytical platform. When you buy SkySpark, it doesn't come with any rules, basically. It doesn't come with any, so you have to either program them yourself or buy a license from someone who's done all that programming work. Does that make sense? So we buy SkySpark as the software, and then we buy a license from BuildingFit, who every month they, you know, do maintenance on the servers and update all of the analytics to the latest thing. And so they're another software company that actually writes the code. Does that make sense? Yeah.
So then, is BuildingFit interfacing with your building automation system?
No, BuildingFit is just residing within SkySpark and they have both like analytical rules, and they also have tools, like other software tools that kind of bolt on to SkySpark. So, but it's all contained within SkySpark. Yeah. Any other questions? Okay, cool. Well, thank you so much for coming, everyone. Appreciate it.